Okay, guys, and now in continuation of the video I made about the hybridization of carbon in ethene, I want to give you the full picture of everything now. Now, this is the structure of ethene. Okay, that's the structure of ethene. Okay, now remember that it forms what? sp2 hybrid orbital along the plane. Okay, this bond is along the plane. Now see the plane here. This is the plane. This is the plane. Remember, this bond is formed with 1x and what? And 2px and 2py. This is the s orbital. So this is the x orbital, and these are the p orbitals. So along the plane, remember, in the axis, like this is the y-axis, this is the x-axis, this is the y-axis, this is the x-axis, like this. This is the y-axis, this is the x-axis, y and x. So this is the z-axis. So this one this is on a plane, that is x and y. Okay, that is horizontal plane. Okay, good. So now see the plane here, this plane, correct? Now see one carbon, see the other carbon. So this is it, the sp3 hybrid orbital bonding to this other carbon, sp3 hybrid orbital, along this plane. Now, the unhybridized p orbital, that is the orbital here, the p0 orbital, the unhybridized p orbital, which each contains what? Pz, contains one electron. That is, one electron is in each orbital. One electron for the pz orbital of this one, another one electron for the pz orbital of this carbon. Correct. Now see the pi bond now. Now from this C now, we have the upper part of the orbital now and the lower part of the what? The orbital. Like this. So this is up and down, the axis is up and down. Yeah. So for this C again, we have the upper part of the orbital and the lower parts of the what? Of the orbital. Good. Now, remember, they will now overlap by the side. Do you understand? That is what we call it, collateral overlapping. This one will overlap with this one, up, above and below the plane. That is the sp3 plane. That is the orbital plane. Okay? So now they will come together to bond. So that means I have to increase this the size of this orbital so that I will show you how they overlapped, okay, forming pi bond. So this is it. Look at they now overlapped like this, forming a pi bond. Yeah. So up and down. This is the overlapping up. This is this region, this shaded region is the region, the overlap region. This is where they overlapped. Yes. So this one will come again. Let me increase the size like this. Let me increase the size of this one like this. So this is it. So you see this pi bond. This is the bond. This is the pi bond we are talking about. This one, this second bond. This is it here. Yeah, that's the pi bond. Okay. Now I've given you a picture. This overlap, the overlapping of these orbitals, it occurred because they are on the same plane. Do you understand? That is the sp3 is on the same plane. The sp3 of this one is on the same plane with the sp3 of this one. If there is a slight deviation, this overlapping will not be possible. That is this pi bond now. It will not be possible. Now, because they are on the same plane, that makes this pi bond to be what? Possible. Okay? So that is it. You know, I said this before that chemical bonds form as a result of what? Maximum overlapping of orbitals. Yeah, yes, maximum overlapping of orbitals. Yeah, that's how they form, and that's when there is a maximum overlap, they will now become stable bonds. Okay, so this is the picture. Yeah, this is the picture. So I hope it is very clear. This is up above the plane. This is below the plane. Okay. So that is it. Now, my next video will be on ethene. Yeah.